Let's use this investigation to illustrate inverse proportion. Our focus question is, how does pressure affect the volume of a trapped gas? X, the independent variable, is pressure, that's what we're going to vary, and Y is volume of the trapped gas, that is the dependent variable that's going to vary because we vary pressure. This is our apparatus we use. We have a syringe, we trap some gas, probably air, inside the syringe, close the end, and then we load various amounts of mass on the plunger. So the mass loaded on the syringe is our indicator of pressure, and we measure the volume of the trapped gas to tell us the relationship between pressure and volume for a trapped gas. Now, if you just think about this logically, of course, if you're going to push harder on the syringe, then the air is going to be compressed more, it's going to take up less volume. So the more you push, the less volume it takes up, the more the less. But we still need to see if it's by the same factor. So here we have some data. It's only partial data, there's some gaps. You need to fill the gaps in. If you can already see the patterns inside the data, then you pause the movie right now and fill in the gaps. If you can't yet see the patterns, let me try and show them to you. So we can see that treatment 1 and treatment 2 differ in that we put double as much mass on the syringe in treatment 2 compared to 1. As a result, the volume of the trapped gas is half in treatment 2 than it was in 1. 1 times 2 equals 2. 15 divided by 2 equals 7,5. Let's compare the first and third treatments. Compared to the first one, we've tripled the mass placed on the syringe, and as a result, the volume of the trapped gas has thirded, has decreased by a factor of 3. 1 times 3 gives you 3. 15 divided by 3 gives you 5. Compare the first and the fourth treatments. 1 times 4 gives you 4. 15 divided by 4 is 3,75. Let's maybe take some less nice looking numbers. Let's increase the mass loaded on the syringe from 3 to 4. 3 times 4 over 3, in other words 1 1/3, is equal to 4. 5 divided by 4 over 3, which is the same thing as multiplied by 3 over 4 equals 3,75. Because of the relationship that I've just described, the product of x and y is constant. 1 times 15 equals 15. 2 times 7,5 also equals 15. 3 times 5 equals 15. 4 times 3,75 equals 15. Now you pause the movie as you fill in the remaining gaps. Is this what you got? So perhaps the easiest way to fill in the gaps is to say 15 divided by x. 15 divided by 6 equals 2,5. 15 divided by 7, 2,14. 15 divided by 8, 1,88. Another way is to just use the kind of patterns I was showing earlier. For example, we can see how we get the bottom number in a number of ways. We could say 1 times 8 gives you 8, so 15 divided by 8 gives you this bottom number, 1,88. Or we could say 4 times 2 equals 8. So 3,75 divided by 2 will give us this number, and it does, 1,88. 4 times 5 over 4 equals 5. 3,75 divided by 5 over 4 equals 3. 5 times 6 over 5 equals 6. 3 divided by 6 over 5 equals 2,5. Notice that 3 divided by 6 over 5 equals 3 times 5 over 6, which is 15 over 6, which is what we have over there. 6 times 7 over 6 equals 7. 2,5 divided by 7 over 6 equals 2,14. Now plot a graph of this data. On the x-axis we have the mass loaded on the syringe, and on the y-axis the volume of the trapped gas. Pause the movie until you've done this yourself. Is this the graph that you got? Why don't you answer these questions while you pause the movie? When you're through, unpause and check yourself.